Hello everyone, welcome back. Wish you all a very happy Independence Day in advance. Take care of yourself and take an oath this particular Independence Day. You'll get a freedom from the things that you're scared, right? Take care of your health, mental health, physical health. Believe in yourself. Always believe that you are doing something extraordinary. Take an oath that this particular Independence Day, you'll start doing some good things as far as your aim is concerned or goal is concerned. So welcome back everybody. We are again in the session of PYQ, IIT Kanpur PYQs, and we are dealing with the topic production engineering. Now this is what second session. Yesterday we solved the numericals as far as casting is concerned, but now today we'll solve so many questions in a very rapid manner and we'll understand the fundamentals behind that. And we'll also try to understand the logic and the basic fundamental how to solve these numericals. So just ask your friends to join the session. So we'll start our very beautiful session which is coming up your way. Again, I'll say that welcome aboard. Mark your presence by joining the session. You can press the like button if you like that. Okay, everybody, write down in the comment box so that I'll get an idea that who are present here. So yes, come in. Okay, fine. Beast, okay, fine. We'll definitely try to be sure that the fundamentals are getting covered in the best possible manner. So shall we kickstart our session? It's almost 2 minutes over. Every minute is very valuable for us because we have to solve at least the 30 questions with the basic fundamentals today from the entire background of a manufacturing process or mechanical engineering. So let me introduce myself. Everybody knows that I did my MTech from IIT Kharagpur, All India rank 79, and I deal with the two subject production and industrial engineering. In the comment box, I have given my Telegram channel. You can join the Telegram group so that the update of these subjects and the classes you'll receive. Right? Fine. So we are dealing with what IIT Kanpur series. So I request that rest of the students also you can convey the message. It's a free of cost, right? Fine. You have to join and you can gain a very good fundamental knowledge. Fine. Now there is one session conducted by Abhinav Negi, or it is about to get conducted on the 14th August. So you can join that particular session, right? Fine. So now let's say that, sir, we are starting metal cutting operation. So write down in the comment box who are present so that I'll get to know that who students are present so that we'll kickstart our session. Everyone. So just write down something in the comment box so that I'll get to know that who are present. So we'll kickstart our session. Press that like button, comment something in the comment box, and we'll definitely understand your particular pulse so that we'll interact to each other. Are you okay, everybody? Okay, fine. Shall we move in the forward direction? Yes. So we'll kickstart our first question immediately. Under certain, we are talking about metal cutting operation, and today we are focusing on more and more questions until only 30 questions are not over. Okay. Nancy Kumari, it's Nancy Kumari. Okay, fine. I'm new here. Don't worry. We are covering everything in a basic fundamental manner. Each and every session has its own purpose. We are in the session of PYQs. PYQ stands for previous year questions, which is conducted by IIT Kanpur. Only that questions we are solving here with understanding of fundamentals. But when we come up with a series where we are talking about fundamentals, at that time we are going to teach you the fundamentals of that topic. So let's take a first question now without wasting a time. So under certain cutting conditions, doubling the cutting speed reduces the tool life to 1/16th, right? 1/16th of the original. So whenever the cutting speed increases, then the tool life reduces to 1/16th. The Taylor's tool life index N for this workplace combination will be. So for this condition, you tell me how much will be a tool life index N. Now how to solve that, sir? We know that Taylor's tool life equation, the basic Taylor's tool life equation is V into T raised to N exactly equal to C. V stands for cutting velocity, T stands for tool life, small n stands for a tool life index, and C stands for Taylor's constant. So if I consider this would be my first particular equation. If I consider that, let's say that this would be my first equation in the series. Now what will be the second equation? It's very simple that we are increasing what? Cutting speed. So what will be new cutting speed? It will be a double of original one. So we'll say that, sir, new cutting speed V1 will be exactly equal to 2 times original cutting speed. Right, fine. Everybody solve this question. Okay, fine. And then the new tool life will be a 1/16th of original. So I'll say that new tool life will be 1/16th time a original tool life. As this is the similar cutting conditions, can I say that C, that is constant, will remain same, and small n, that is exponent, because it depends on the material properties. So small n, that is called as tool life exponent, or a tool life index, will remain constant. So now this is exactly equal to my equation number 2, right? Or we can write down this equation number 2, that is V, cutting speed is how much? 2 into V. That is tool life, new tool life will be 1 by 16 times T to the power of n is exactly equal to C. So this will be my second equation. This will be my what? Second equation. So you compare the equation 1 and equation 2, as simple as that. So C constant will remain same. So left hand side we can compare. So once you compare that, I'll write down here, it will be V into T to the power of n is exactly equal to 2 into V into 1 by 16 into T to the power of n, right? Fine. So can I say that from here, if I cancel V, that is cutting speed, remain constant, same, so I can cancel that. Okay, very good. Then T to the power of n and T to the power of n will get cancelled. Is it so? No, this is not the way, because we have to calculate what? We have to calculate n, we have to calculate from here. So I'll say T to the power of n is exactly equal to 2 into T to the power of n divided by 16 to the power of n. 16 to the what? Power of n. So I'll say that I'll take it this 16 to the power of n, and then 2 to the power of n will get cancelled. 2 will remain here. Is it true? Yes. So now you do one thing, that take a log of both sides. If I take a log of both sides, I'll say that it will be coming n into ln 16 is exactly equal to ln 2. And if you solve that, can I say that you'll get a value of n is exactly equal to ln 2 divided by ln 16. So you tell me that how much answer is coming? Is there anyone calculated answer? How much answer is coming? So I'll say that you'll get an answer n is equal to 0.25. 0.25. As simple as that. So my answer will be 0.25. So what do we understand from here? So we understand one thing, that whenever such conditions are coming, we have to compare the Taylor's tool life equation, right? Under similar condition, constant will remain same. And under, if I use the same tool, the Taylor's index n will also remain same. So we have to just compare that. Is it true? Yes. So this is what exactly my answer is, n is exactly equal to 0.25. Is it true? Okay, Nancy Kumari, it's very true that how can I solve? This is for PYQs or the students who are already studied, right? Fine. Okay, next question. The question is that the angle of twist drill that determines its rake angle is. So you tell me that there is a twist drill, right? So which angle of the twist drill will determine rake angle, whether it's a leap angle or chisel edge angle, helix angle or point angle. So if I go and understand the geometry of the twist drill, you understand that there is one angle, it's called as helix angle. So what is the helix angle? So this is exactly equal to my chisel edge. Can you understand that? This is what exactly chisel edge. So we understand that the angle made between leading edge and the axis of the drill bit. What is the axis? This is what exactly axis of the drill bit. And this is what exactly can I say that, sir, this is exactly equal to a edge. Right? This is what exactly edge. This is nothing but called as leading edge. This is leading edge. What is leading edge? So we can understand that, sir, this is my leading edge. Let me show that which one is the leading edge. So I can say that this is my leading edge. This is what exactly my leading edge. An angle made by leading edge with the axis is nothing but called as a helix angle. It is written alpha. And you can easily understand that from the center, can I say that this leading edge angle or this angle made by leading edge with the axis of the drill bit is continuously increasing. And at the outer periphery, can I say that it will become maximum? At the outer periphery, it will become maximum. So that maximum angle defines my what? Rake angle. So we can say that very simple. The angle made between leading edge and the axis of the drill bit, which varies from central axis towards the periphery of the drill and which is become maximum at the periphery, that angle is nothing but called as rake angle of the drill. Rake angle of the drill. So what is my answer? So I'll say that helix angle will decide rake angle of my drill bit. Is it understood? Yes. So helix angle is definitely my answer. Helix angle is definitely my answer. Now some students are definitely commenting that how can I understand? How can I understand some fundamentals because they haven't studied the fundamentals, right? Fine. Okay, do understand, but what sessions we are in right now? We are in the PYQs. Whenever we are coming up with the new sessions where we are dealing with the fundamentals, in that session definitely you will going to understand it, right? Fine. Next question. Built-up edge formation decreases under the conditions listed below except. So built-up edge formation, we know that. So whenever the chip is coming out, it will start rubbing against the rake surface. And whenever there is a friction takes place, lot of heat energy is released, and there might be chances that microchips might get stick to the rect surface or cutting edge, and because of that there is one new edge is getting built up, and therefore it is nothing but called as built up edge formation. Is there anyone who can answer that? The built up edge formation decreases under the condition listed below, except. So except which condition? The built up edge formation will decrease. So at low cutting speed. At what? Low cutting speed, using large positive rake angle with sharper tool using cutting fluid. So we know that, sir, if I use a cutting fluid, definitely built up edge formation will reduce. With a sharper tool also, the built up edge formation will reduce. Using a large positive rake angle also, can I say that the built up edge formation will decrease? But when at the low cutting speed, what will happen at low cutting speed? The low cutting speed, there will be a large time will be present, so or the chip will be having larger time so that they can easily get stick to the rake surface. So we can come back here. When the chip is coming out, can I say that chip velocity will solely depends upon cutting velocity. If the cutting velocity is very high, chip velocity will be very high. Right? So if the cutting velocity is very high, chip velocity high, and chip will flow away from the rake surface quickly. And therefore that chip doesn't get enough time to get stick to the cutting edge and the rake surface. So the chances of formation of built up edge will decrease. But if my cutting edge is very low, then the chip velocity will be low, so chip will get exposed to the high temperature, and it will get very high time to get stick to the rake surface, and it will definitely get stick to the rake surface and the cutting edge, and therefore built up edge formation might take place. And therefore we can say that, sir, at low cutting speed, the chances and tendency of generation of the built up edge formation will increase. So therefore I'll say that, sir, my A will be perfect answer for this. Do you understand that? A will be my answer here. A will be my answer here. No doubt into that. This is what exactly my answer will be. Is it true? Yes. Right. Should I go to the next question? If you have any doubt, you write down in the comment box. If you have any answer, you also write down in the comment box. So the more and more you interact with me, we will understand the philosophy of each other. Is it true? Yes. One more beautiful question was asked in a GATE examination. And what was that question? During orthogonal cutting of MS with a mild steel material with a 10 degree rake angle of the tool, that is orthogonal rake angle, the chip thickness ratio was obtained as 0.4. The shear angle in degrees evaluated from this data is. It's very simple. Whichever data is given, you write down the data, and based on that you try to find out the answer. So we know that alpha 0 or alpha is a rake angle of the tool, that is 10 degree. Okay, fine. Then chip thickness ratio R is exactly equal to 0.4, and we are interested to calculate shear angle phi, that is question mark. Shear angle phi we are interested to calculate. This is the data given. So we have written that data. Now the question is that, sir, is there any relation between the rake angle alpha, chip thickness ratio R, and the shear plane angle phi? So there is one standard formula is there. And what is that standard formula? We know that, sir, tan phi, how many times I told you that this is exactly equal to heart of entire metal cutting. Every now and then, for solving number of numericals, we require this formula. What is that? Tan phi is equal to what? R into cos of alpha 0 divided by 1 minus R into sine of alpha 0. Is it true? Abhishek, hello everybody. Abhishek, hello. Just write down. Tell me the answer. Okay, fine. So chip thickness ratio you know. The rake angle also you know. Put the value there. So I'll say tan of alpha 0, sir, is exactly equal to chip thickness ratio is 0.4. The rake angle is 10 degree. R cos alpha divided by 1 minus R, that is 0.4 into a sine of 10 degree. Is it true? Yes. So therefore alpha 0, that is rake angle. Sorry, not alpha 0. It has to be shear plane angle phi we are calculating. So I'll say phi is exactly equal to. How much phi you calculated? Is there anyone who calculated that answer? So answer is coming 22.94 degree. 22.94 degree would be answer is coming. And I'll do one thing that now I will just make available. I'll take and convert that into PPT or PDF file, and this PDF I'll just post into my Telegram channel after this particular session. So you can download from there. So for downloading that, because I was not aware that how to communicate with the student, so now I get understanding that this particular PDF of the questions we have solved with the solution, I'll be updating to the Telegram channel in the evening, so you can download there. For that you can join my Telegram channel. Hi sir, good to see you. Okay. Dileshwar, okay, fine. Abhishek, everyone is understanding. So my answer is 22.94 degree. So C will be my answer. Today we are not wasting a time, and we are trying to cover as maximum fundamental numericals as concerned with the fundamentals 1. Is it true? Yes. Are you accepting everyone? This is answer? Yes. So next question is, was it true? Yes, fine. Next question. For turning nickel chromium alloy steel at a cutting speed of 64 meter per minute and 100 meter per minute, the respective tool lives are 15 minute and 12 minute. So whenever there is a one particular nickel chromium alloy steel, right, for that we are doing cutting operation at different cutting speed. The cutting speed first of all is 64, then it is 100, and 64 respective we get a tool life that is 15 minute, and respective 100 meter per minute tool life is 12. The tool life for the cutting speed of 144 meter per minute. This is one more scintillating question every now and then is coming, and how to solve that is very simple. So there are three cases are given. For first two cases, you take it, and from that first two cases, you calculate, try to calculate small n value or c value. So what is Taylor's tool life equation? We know that Taylor's tool life equation is V into T raised to n is exactly equal to C. N stands for Taylor's exponent and C stands for Taylor's constant. So can I say that n depends upon, small n depends upon tool material. All the cases which is given, can I say tool material remains same? So small n value will remain same. Is it true? Small n value will remain same, and C depends upon cutting condition. Cutting conditions also same. So can I say that C value will also remain same? So you do one thing, that whichever the two cases are given to you, with respect to these two cases, you try to find out small n value or small c value, and once you get that, for the third cases, unknown values can be calculated. So how exactly it can be done? So I'll take this data. What is the data given? Sir, my cutting speed is 64 meter per minute. Against that, tool life is 15. My cutting speed is 100 meter per minute. Against that, my tool life is 12 minutes. So should I write down this data here? Yes. So I'll say that my cutting speed, how much is cutting speed? So we'll say that cutting speed or cutting velocity is 64 meter per minute, and against that, my tool life T1 is exactly equal to 15 minutes. Is it true? Yes. For this, can I write down the equation? Taylor's tool life equation? Yes, sir. Definitely. What is it? V into T raised to n is exactly equal to C. V is what? 64 into T raised to n. So I'll say T1. So instead of T1, I'll say that 15 raised to n is exactly equal to C. I'll say that this will be my equation number 1. This will be my equation number 1. Try to understand that this is the way by which these kind of numericals has to be solved. Now second data. What is the second data given in the problem? Sir, second data is given that cutting speed is exactly equal to 100 meter per minute, and against that, my tool life is exactly equal to how much? It is 12 minutes. It is what? 12 minutes. Now for this also you write down what? The Taylor's tool life equation. Okay, V into T raised to n is exactly equal to C. Cutting speed is 100. Taylor's tool life equation 12 into n is exactly equal to C, and this will be called as my equation number 2. So now you do one thing, that you compare equation number 1 and 2. You equate that because C will remain same, because cutting conditions are same, constant will remain same. So by comparing equation 1 and 2, by what? Comparing equation 1 and 2, I'll say 64 into 15 to the power of n is exactly equal to 100 into 12 to the power of n. Is it accepted? Yes. Now you 64 take to the right hand side. So I'll say 15 divided by 12 raised to the power of n is exactly equal to 100 divided by 64. You take log of both sides, and then you will calculate value of n. Can you able to calculate? Yes, definitely n can be calculated here, and then exponent value is coming as exactly equal to 2. So this is exactly equal to my Taylor's exponent is coming. So what do we understand from here? We understand that first of all, we have to calculate either C value or either small n value. And once we calculate that value, then use that value to calculate the unknown values which is asked in the problem. So what is that? The tool life for cutting speed of 144 meter per minute. So now third condition is there. So I'll say that V3 is 144 meter per minute. How much is a tool life? This is question T3 we have to calculate. So for this condition also, can I able to write down this equation of Taylor's tool life? Yes, sir. So I'll say that V3. What is that V3? 144 into Taylor's tool life T3 raised to the power of n. So instead of n, I'll directly write down 2 is exactly equal to C, and this will be my equation number 3. This will be my equation number 3. Same condition, constant will remain same, small n value will remain same. Yes. So this equation also can be rewritten as 100 into 12. Instead of n, we can written as 2, and this is also equation C. So can I compare this equation 2 and 3 now? Can I compare equation 2 and 3? Yes. So I'll compare equation 2 and 3. So I'll get 144 into T3 raised to the power of 2 is exactly equal to 100 into 12 to the power of 2. So can I able to calculate T3 here? Yes. So how much is T3 can be calculated? Yes. So T3 coming is 10 minute because entire tool life was given in the minute. So this also will come as a minute. This will also come as what? Minute. So I'll say that, sir, this will be my T3 and this will be exactly equal to 10 minute. So whoever is present here, mark their present by commenting something so that I'll understand that whether you're solving these numericals or not. These sessions are dedicated to you. We have discussed that those students who are appearing for GATE examination and already studied this topic, they'll come and practice with us. Right, fine. Because this is what motive behind IIT Kanpur BYJU'S. Now some students are asking, sir, where are fundamentals? How can we solve the numericals without fundamentals? We do agree that. So when I'm coming into the paid batches or whenever I'm coming to the live sessions where I'm going to discuss fundamentals, where each and every fundamentals will be discussed. I hope you are understanding. So what is the answer for me? A 10 minute. So C is exactly equal to answer for me. Is it accepted, everybody? Yes. Right? Write down in the comment box so that we understand how exactly things are going. Yeah, based. Okay, fine. Next question we are solving now. In orthogonal turning of a low carbon steel pipe with a principal cutting edge angle, with what? Principal cutting edge angle of 90. The main cutting, now you tell me that what is principal cutting edge angle? It is approach angle, lambda. It is 90. If the principal cutting edge angle lambda is 90, so side cutting edge angle is exactly equal to what? 0. Side cutting edge angle is what? A 0. The main cutting force is 1000 Newton and the feed force is 800 Newton. The shear angle is 25. Orthogonal rake angle is 0. Employing the merchant's theory, the ratio of friction force to the normal force acting on the cutting tool is. So we are interested to calculate ratio. किसका ratio calculate कर रहा है? Friction force to the normal force. It was given, right? Friction force to the normal force. So now I know that, sir, whenever we go to the orthogonal cutting operation, or I'll say that, sir, the orthogonal turning for which we do the analysis. So this angle is nothing but called as approach angle lambda. And this approach angle lambda is nothing but called as a principal cutting edge angle. This is exactly equal to 90 degree. If this is 90 degree, can I say side cutting edge angle is exactly equal to 0 degree. This is basic fundamentals. If you understand that, it's very good. If not, then you have to go and understand these fundamentals by yourself. Is it true? Yes. Now what is the data given? You write down here. Sir, cutting force आपको दिया है. Right, fine. So whichever data is given to you, please write down there. So I'll say that, sir, cutting force FC is exactly equal to 1000 Newton. Right, fine. Okay. Then a feed force, that is axial force, is given is exactly equal to 800 Newton. Feed force is given what? 800 Newton is a feed force given. Right, fine. The shear angle, that is shear angle phi, is given as 25 degree. Is it right? Fine. Orthogonal rake angle is 0, that is alpha 0 is exactly equal to 0 degree. Right? Apply Merchant's theory, and based on that, you tell me that what is the ratio of friction force divided by normal force. If I ask you that, can I say the friction angle or the coefficient of friction mu? What is the definition? Sir, it is also exactly equal to a friction force divided by a normal force. It can be also written as friction force F divided by normal force N. F by N is exactly equal to mu. And now I'll ask you that you are interested to calculate friction force F divided by normal force N. In the analysis of a Merchant's theory, in the analysis of the forces comes in the metal cutting operation, we must have developed the number of equation to relate the cutting force and the actual force or thrust force with the friction force as well as normal force. Do you remember that? This is the standard fundamentals, right? Fine. So what is that? I'll write down the friction force in terms of cutting force and actual force can be written as Fc into sine of alpha plus the thrust force Ft, or it can be called as axial force or feed force in terms of cos alpha divided by normal force. How it can be written as? It can be written as the cutting force into cos of alpha minus a thrust force, that is axial force, into a sine of alpha. Now you'll ask me again, sir, what the hell is this? These are the fundamentals. You must have been assume and understand that while preparing in the previous session. If you understand that, it's very simple. Now cutting force value you have to put, axial force or feed force value you have to put. So what is the cutting force value? We know that, sir, cutting force is 1000 Newton, right? Fine. Axial force is what? Axial force is 800 Newton. Okay, fine. The alpha value rake angle is exactly equal to 0 degree. You put it there and you'll get friction force F divided by N. That is mu value is coming. And what is value? That is 0.8 value you must have calculated. Is there anyone who calculated that value? Most of the students are saying, sir, we are blank on the basis of fundamental only. How to solve it? So 0.8 is exactly answer for me. So I'll say that, sir, 0.8 is exactly equal to answer for this particular session. Is it true? Yes. So this is exactly equal to 0.8 is the answer. 0.8 is my answer. Right, fine. We'll go to the next question now. Is it correct, everyone who is watching session? Fine. Again, there is one question comes in a examination. In an orthogonal turning of a medium carbon steel, the specific machining energy is 2 kilojoule per millimeter cube. Right, fine. The cutting velocity, feed and depth of cuts are given respectively 120 meter per minute, 0.2 mm per revolution and 2 mm respectively. The main cutting forces. Now, first of all, you tell me that what is meant by a specific cutting energy. So, specific cutting energy is nothing but amount of energy required to remove unit volume of material is called a specific cutting energy. Amount of energy required to remove unit volume of material is called a specific energy. It can be written as total energy per into volume. कितना energy चाहिए unit volume of material remove करने के लिए, that is what is called as specific cutting energy. Now, what is the formula for specific cutting energy? So, specific cutting energy is exactly equal to FC cutting force into VC divided by MRR. MR is nothing feed into depth of cut into cutting velocity. And here that feed and depth of cut, cutting velocity can be cancelled. So, it can be called as cutting force FC divided by feed and depth of cut. Feed and what? Depth of cut. Unit is coming Newton per millimeter square, and therefore sometimes you must have heard that it is also called as specific cutting pressure. It is also called as what? Specific cutting pressure. Specific cutting pressure. Specific cutting pressure. And that was already asked in engineering services somewhere. Calculate the specific cutting pressure. So therefore, we are interested to calculate now cutting force FC. So can I say cutting force FC is equal to specific cutting energy multiply by feed multiply by depth of cut. This denominator you take it to the left hand side. So I'll say that, sir, my cutting force FC will be a specific cutting energy multiply by feed multiply by depth of cut. So what is the data given? Sir, the data is given that 0.2 mm per revolution is feed and 2 mm is depth of cut. So I'll say that, sir, feed is exactly equal to a 0.2 mm. Right, fine, actual feed, and depth of cut D is exactly equal to 2 millimeter, right, and the specific cutting energy is given exactly equal to 2 kilojoule. I required in the joules, Newton into meter, so multiply by 1000. Is it true? Yes, that is joules per millimeter cube. So take, right, fine, take these values. So I'll say that, sir, it is exactly equal to FC. Can somebody tell me what is answer? Cutting force? Can somebody? Okay, 2 into 1000. Multiply by feed. क्या है भैया feed? Feed is 0.2. Right, fine. And depth of cut is 2. So therefore, I'll say that cutting force FC is coming exactly equal to, if I'm not wrong, is there any answer coming to anyone? 800 Newton. 800 Newton. This is my answer is coming. This is my answer is coming. Is there anyone? Okay, who calculated answer? Raise your hand. Okay, fine, I've calculated. Or you are not calculating anything, whatever which way, you just let me know that what is exactly things are there. Do you understand how exactly we are talking about these particular sessions now? Okay, so I'll say that, sir, the answer is exactly equal to 800. Delhi D is perfect answer for this. So what is my answer? My answer is exactly equal to Delhi D. So I'll say that, sir, this is my answer. Delhi D is my answer for this particular session. Is it understood? Yes. Okay, fine. So we'll go to the next question. Orthogonal turning of a mild steel tube with a tool of rake angle 10 is carried out at a feed of 0.14 mm per revolution. If the thickness of the chip produced is 0.28 mm, the value of shear angle and the shear strain will be. This is the very basic question every time is coming. Either shear angle calculate karo or calculate shear strain. Right, fine. So whatever data is given, first of all you write down the data. So I'll say that, sir, orthogonal rake angle alpha 0 is given 10 degree. So I have written here. Right, fine. Feed F is given 0.14 mm per revolution. Right, fine. And the thickness of the chip is given, so I'll say that T1 is exactly equal to chip thickness 0.28 mm. So there are number of fundamentals. Feed is given. So can I say feed can be considered as uncut chip thickness? So this will be considered as a T0, that is 0.14 mm. Right, fine. We are interested to calculate shear plane angle phi and shear strain. We are interested to calculate shear strain value. I hope so you understand all the concepts and fundamentals. Sir, if I ask to calculate phi value, that is nothing but the shear plane angle phi. So can I say that shear plane angle phi ka the standard formula hai, sir? What is that? So tan phi is exactly equal to R into cos of alpha 0 divided by what? 1 minus R into sine of alpha 0. 1 minus R into sine of alpha 0. Is it true? Yes. Sir, we require R. R kya hai bhaiya? What is R? Sir, R is nothing but chip thickness ratio. If R is chip thickness ratio, what does it mean by chip thickness ratio? Uncut chip thickness divided by thickness of the chip, that is T0 divided by T1. All the values are with me. T0 is 0.14. What is uncut chip thickness or what is thickness of the chip? 0.28. So what is answer is coming? 0.5. Alpha 0 rectangle, how much it is? Sir, 10 degree, which is given in the problem itself. So can I able to calculate tan phi here? Absolutely true. There is no problem at all in calculating tan phi. These are the penis questions are asking, and unnecessarily we are getting scared about GATE examination. So this is 0.5 multiplied by cos of 10 degrees divided by 1 minus 0.5 into sine of 10 degrees. Sine of what? 10 degrees. Is it true? Yes. I hope so you are understanding this basic fundamental. And if you calculate that phi, calculate karna kitni badi baat hai. Phi is coming exactly 28.33 degree. 28 point what? 33 degree. I hope so everybody of you must have calculated this particular solution. 28.33 degree. Isn't it? Yes. So first answer to mera aa gaya. 28.33 degree is the shear plane angle phi. Now you tell me that shear strain. Does anyone here know the shear strain equation? Shear strain ka equation kisko pata hai? There is one derivation. You must understand while understanding and going through and understanding fundamental of metal cutting. Very interesting question. Sir, shear strain S is exactly equal to cot phi plus tan of what? Phi minus alpha. Shear strain equation. Basic fundamental. Very correct. Beast and Nancy and then Ravindra and then somebody else is there. Dileshwar. Just write down in the comment box. Do you know that this formula? Shear strain is equal to cot phi plus tan of phi minus alpha. Phi shear plane angle already calculated. Alpha shear alpha rectangle. It is there. So calculate karo na bhai. S is equal to cot of phi. What is that? Sir, 28.33. 28.33 plus tan. What is that phi? 28.33 minus alpha, that is 10 degree. So how much is shear strain is coming? And shear strain, it's a unitless value. Unitless value 2.185. 2.185 is the shear strain. 2.185 is my shear strain comes in the picture. Is it true everybody? Yes. So this is my answer. Shear strain is a 2.185. So 28 degree and 28.33 degree, 28.33 and 2.18, 2.19. So A roughly will be answer for me. How much it is? This A will be answer for me. Is it okay everybody? A mera answer hai. Okay, fine. We'll go to the next question now. A reaming is primarily used for achieving what? A reaming operation is there. You must have heard about that. Drilling operation is there. A reaming operation is there. Boring operation is there. There are three different operations. Reaming, drilling and the boring. So if I go and compare the drilling, reaming and the boring, you can understand that drilling operation is utilized to create a hole of required diameter, and it is a hole created first time in the body. So whenever we are interested to create a hole first time in the body, then drilling operation comes in the picture. So whatever hole is drilled, if I want to enlarge the diameter of that hole, then there is a operation is coming called as boring operation. So boring is a single point cutting tool operation where it is used to enlarge the internal diameter, and whenever the dimensional tolerance that we need to achieve, whenever exact grade of dimension, if I want to manufacture a component with, then the next operation is coming is called as reaming operation. Is it understood? Reaming is basically utilized for what? Dimensional tolerances, right? Fine. To achieve dimensional tolerances. So reaming is used slightly to enlarge the hole to provide a better tolerance on its diameter. Better tolerance on its what? Diameter. So I'll say that, sir. It's not high MRR because it's a finishing operation. Fine surface finish, okay. Improved positional tolerance, but it's basically improved dimensional tolerance, not a positional tolerance. Geometrical tolerance is coming as far as position is concerned. Positional tolerance is different. Position is nothing but what? Geometrical tolerance. I'm talking about dimension tolerance. Dimension means what? Diameter should get manufactured of 10 millimeter. That is called as dimension. Right, fine. So majority of, I would say that the major concern or major use of this reaming operation is to achieve what? A required grade of dimensional tolerance. Bombay B is spot on answer for us. Is it okay, everybody? Yes. Next question. In a machining operation, if the generatrix and directrix both are straight lines, generatrix is also a straight line, directrix is also a straight line, the surface obtained is where is the cylindrical surface or helical surface or a plane surface or surface of revolution. What is it? So we know that basically what is generatrix and directrix, and whenever I'll take a session in the paid session or in the YouTube session, I'll cover that. I'm new to this platform, so students does not know about me much, but these things will be covered in a very detailed manner. So I'll tell you what is meant by generatrix. So generatrix is basically the movement which develop the cut surface. Whichever the movement of the tool with respect to workpiece which developed the cut surface, that direction movement of the tool is called as a generatrix because it is generating the surface. Suppose if I selected a turning operation. So this is what exactly workpiece. In turning operation, workpiece is rotating, right? Fine. And the tool is engaged. So whenever the tool is engaged, can I say that this workpiece is rotating? So can I say along the circumferential surface, my tool is engaged with the workpiece. The tool is cutting the workpiece along the circumference. So this direction, circumferential, this is nothing but generating. It is removing the body. It is cutting the body along that. So this direction is called generatrix. And what is meant by directrix? The movement which direct that cut surface so that volumetric chip will come. So therefore this feed, can I say that tool must be giving feeding? If there is no feed is given and the tool is constant, only placed at one location, and that tool or that workpieces keep on rotating, will there be any volumetric removal? There is no feeding. Actual movement of the tool is zero. The tool is only engaged with respect to workpiece and only workpiece is rotating like that. Will there be any volumetric removal? No. So to have volumetric removal, there has to be feed. Tool has to move, and because of that, there is a chip comes out, and therefore this particular movement which is directing the generated surface, it is called as directrix. It is called as what? Directrix. So here, this is the direction where directrix is there, and this is generatrix. Generatrix is circular, directrix is linear. Generatrix is circular, directrix is linear. Generated surface will be cylindrical one. Generated surface will be cylindrical one. In the same manner, if you go for a shaping and the planing operation. Now you don't understand and ask me what is shaping and planing. Here, this is the direction in which my tool is moving. So this is the direction in which the cutting takes place. So this is a cut section generated. So this is nothing but my generatrix. So can I say that, sir, direction of movement of the tool with respect to workpiece is generatrix. So this is my generatrix. Yes, fine. And to generate a volumetric movement, can I say this is the direction where the feed is given. This is the direction in which what feed is given. So this is nothing but directrix. What is the surface it generates? Can I say it generates what? Plane surface. So when the generatrix is linear, directrix is linear, the surface which manufactured in the shaping and planing is what? Plane surface. Which surface? Plane surface is generated. So we can say that, sir, definitely a plane surface will be my answer. What will be my answer? Plane surface will be my answer. Is it understand? Okay, fine. I know that, sir, if you haven't heard this concept yet, and then to discuss and talk about and understand this concept will be very difficult, right? Fine. Because I only speak fundamentals. I give the reasons because you understand one thing that Ravindra, Thube sir only speak truth. That's the only story. And that he speaks only what? Fundamental concepts. Root of everything is fundamental concepts, right? And I speak simple statements, right? Fine. I hope so you're understanding this. Right, student will increase when they come to know that. I'll come with the new sessions when we start these sessions, when we go into the paid batches, when the students come to know that, you'll see the different dynamics here will change. No worries. Okay, now we'll start solving questions of sheet metal operations. Straight away we are moving to the sheet metal, and quickly we'll go and talk about sheet metal operations also. What is it now? So we are going to the sheet metal operation where we'll discuss the questions from metal forming and sheet metal operations. Are you ready, everybody? Let's talk about first question. In an open die forging, very basic questions are coming. a disc diameter 200 mm and the height 60 mm is compressed without any barreling effect. Without any barreling effect, the final diameter of the disc is 400 mm. The true strain is. So there is one particular cylindrical rod is selected, then the diameter is 200, then it is a forging operation, the force is applied. So when the force is applied, the length will reduce and the diameter will increase. So diameter has increased from 200 to 400. Calculate the true strain. First of all, you tell me the definition of true strain. Do you know that how to calculate true strain? Oh my God, sir, it's know that true strain is exactly equal to ln L naught divided by original length divided by final length. L naught divided by LF. L naught divided by LF is the definition of true strain. L naught stands for original length, LF stands for final length. Yes, fine. You must have heard that one fundamental rule in the fundamental metal forming process. The material is incompressible. Volumetric changes are negligible or considered as zero. This is what exactly assumption in every metal forming process, whether it's a rolling, extrusion, forging, anywhere. So therefore, can I say that volume before the plastic deformation and volume after the plastic deformation will remain same. If there is a cylindrical body, what is the volume? Cross-section area multiplied by length. Cross-section area multiplied by length. So can I say that original volume is A naught into L naught. Here I can consider H naught, or it can be considered as L naught, which is exactly not H naught or L naught. Directly I'll say that L naught. Right, fine. It is exactly equal to final cross-section area multiplied by a final length. It can be written as final cross-section area multiplied by final length. Right, fine. So now original length and final length is not given, boss. Original diameter and final diameter is given. So that original length divided by final length, you can replace in terms of cross-section area or diameter. So you do that. So I'll say that LF by L naught you take it to the right hand side. So I'll say that it will be A naught divided by A1. A naught divided by A1 or AF is exactly equal to LF divided by what? L naught. Is it true? Yes. So L naught by LF. We required, sir, oh my God, I required opposite of that. Okay, fine. So you do opposite of it, no issues. So I'll say that, sir, L naught by LF is exactly equal to AF divided by A naught. AF divided by what? A naught. Is it true? Yes. AF divided by A naught. Is it correct? Epsilon true strain is exactly equal to this one. Is it accepted, everybody? Yes. So therefore I'll say that true strain is exactly equal to Ln, and then I'll say that AF by A naught. AF, what is that final cross section area? Pi by 4 into what? Diameter. Final diameter is 400 square. Is it true? Yes. Is it true? Yes. So I'll say that, sir, how much it is coming here? Right, divided by A naught. A naught is what? Pi by 4 into D naught square. Right, fine. So you tell me that how much true strain is coming? So true strain will come exactly equal to. How much it is? How much true strain is coming? Minus 1.38. And the minus is coming because the length is reducing here. Because we are compressing, right, fine. The diameter is increasing, but length is what? Reducing. And that's why true strain. Negative sign of the strain only indicates that. Negative sign of the strain only indicates one thing. And that is nothing but what? That is only one thing, which is nothing but, sir, the dimension is reducing. Dimension is what? Reducing. Is it true? Yes. So my answer is what? This one. Is it okay, everybody? 25C, correct. Beast, this is what exactly answer is coming. Is it true? Yes. Okay, we'll go to the next question now. Now this question, it has been observed that number of times this is a very simple question is coming, and this is what exactly drama. In a slab rolling operation, in what? A slab rolling operation. Now you check that whether the answer is coming minus or positive. And this is what exactly definition is taken as far as forging operation is concerned, where the dimensions are being reducing. So this negative might not come here because already we have replaced this particular, that is L naught by LF. I think so. Right. Okay, fine. We'll come back here. In a slab rolling operation, the maximum thickness reduction is delta H max. It is given by delta H max is equal to mu square into R. So direct formula is given in the paper itself, where R is the radius of the roll and the mu is the coefficient of friction between the roll and the sheet. If mu is exactly equal to 0.1, friction is 0.1, the maximum angle subtended by the deformation zone at the center of the roll. So angle made by entry and exit point at the center of cylindrical roller is called as angle of bite, bite angle, deformation angle, or angle subtended at the center of cylindrical roller. And that angle subtended is written as F or alpha that we are interested to calculate. And maximum reduction possible is given here. Delta H max is exactly equal to mu square into R. Mu square into what? R. Is it true? Yes. And value of friction mu is given exactly equal to 0.1. Can you able to tell me what will be answer here? So if you go here, so this is what exactly plane sectional view of a rolling operation. So this is my entry point of rolling operation. This is my exit point. And the angle made by entry and exit point at the center of cylindrical roller, this angle is nothing but called as angle of bite, bite angle or deformation angle. And we know that if the angle of bite is increasing, deformation angle is increasing, what will happen? What will happen? Reduction takes place in the thickness direction will increase. This is nothing but a thickness reduction. This is delta H by 2. This delta H by what? 2. If I say that this is my thickness H0, if this is my H0, this will be exactly equal to H1, and whatever it is mentioned here is a reduction in the thickness. And we know that, sir, during the rolling operation, there is no pushing force and no pulling force. So who is dragging that metallic strip into deformation zone? It is a friction generated between circumferential surface of roller and the strip material. The strip is getting dragged. But to allow that strip to get dragged into deformation zone, there has to be certain friction has to be generated. And if you don't allow to generate that friction, my roller will keep on slipping. And therefore, there is one fundamental rule is developed. So allow the roller to drag the metallic strip into a deformation zone. To allow the roller to drag the metallic strip into a deformation zone, the maximum value of alpha, that is maximum value of alpha, could only reach to friction angle beta, or it is nothing but the friction angle beta should be always greater than equal to alpha. Beta is nothing but friction angle. The friction angle should always kept greater than equal to alpha. Alpha is nothing but bite angle. So bite angle can never be greater than friction angle. The moment my bite angle becomes greater than friction angle, the sufficient friction will not be there and rollers will keep on slipping on the surface of this particular strip material. So therefore, this is what exactly basic fundamental rule is. And therefore, can I say that, sir? Then maximum value of bite angle could be exactly equal to friction angle beta. So alpha max could be exactly equal to beta. Is it understood? Yes. Now beta is nothing but what? Friction angle. Beta is what? Friction angle. So can I say friction angle beta is nothing but a tan inverse of mu? Tan inverse of mu. Because we know that mu, that is coefficient of friction, can be calculated by formula tan of beta. So therefore I know that, sir, mu value is there 0.1. We are interested to calculate what? The alpha max. So can I say that here alpha max is exactly equal to tan inverse of mu, that is 0.1, and therefore alpha max, that is maximum angle subtended at this particular center. How much it is calculated? If you calculated that, it is exactly equal to 5.7 degree. Is there anyone who has calculated this? Is there anyone who has calculated this? I hope so. You must have calculated, everybody. 5.7 degree. 5.7 degree. Is it okay? The temperature is rising, the heat is rising here. So just download the app, just subscribe the channel, watch the videos, understand fundamentals. I do understand that I'm new to the channel, so that you might not attend my the sessions of fundamentals, but gradually it will happen. I'm guaranteed that, and you will never regret attending my sessions. Okay, next question. In a two-stage wire drawing, अब देखो ये इतना fundamental question है, and 3-4 times in the recent years in many competitive examination is asked. Let's say that, what is that question? In a two-stage wire drawing operation, the fractional reduction ratio of changes in cross-sectional area to the initial cross-sectional area in the first stage is 0.4. So in the first stage, the fractional reduction is 0.4, and the fractional reduction in the second stage is 0.3, the overall fractional reduction. Students say that, sir, in first stage 0.3 or 0.4, in the next stage 0.3. So overall fractional reduction is exactly equal to my 0.7, and therefore answer will be 0.7. But if you go to the option, so it is not option. So what is answer for this? You tell me, boss, what is answer? So I'll tell you simple story here. I'm selecting one cross-sectional area, right? One rod select किया, उसका cross-section area है A1, A0. कौन सा भी rod, अरे any rod you selected boss, there is any rod who has certain diameter, which means that who has certain cross section area. In a first stage, we are reducing the cross section area of that rod. And by how much? It is reducing by 40%. 0.5 is a fraction. So how much it is reducing? 40% reduction takes place. 40% reduction takes place in the cross section area. अब मुझे बताओ, if the reduction in the cross section area is 40%, how much it will remain now? How much it will remain? Reduction हो गया 40%. So can I say remaining will be 60%? That means 0.6 into A naught is the remaining cross section area after the first stage. Now it might be anything, any cross section area. Original cross section area is something, it is reduced by 40%, remaining is 60%. Now this cross section area rod I am selecting, and in next stage, again it is reducing. Again it is reducing by how much percent? 30%. 30% further reduction takes place. If 30% is further reducing, how much will be remaining? 70% of the original, 70% of not original, 70% of this, 0.6 into A naught. So I'll say that 0.7 into 0.6 into A naught is my cross section area right now. So that means it is exactly equal to 0.7 into 0.6 is 0.42 into A naught. So can I say that in a simple statement, I'm selecting one rod of cross section area. In a multiple stages, I'm reducing by certain percentage, and after it reducing, my final cross section area is 0.42 times original. So right now, my cross section area is 0.42 times original. So how much it has reduced? So can I say that a reduction takes place is exactly equal to 1 minus 0.42? That is exactly equal to 0.55 is a fraction. So if I ask you that in percentage, you tell me that multiply by 100. So can I say that it will be a 58% reduction takes place? Right, very correct. Beast, incarnate, absolutely correct. 0.58 is answer. That is what exactly. Fraction, if you ask me, 0.58. And if you ask me the percentage will be exactly 58%. So sir, this will be my answer. This will be my answer. Golden answer will be this much. Is it okay, everyone? This is my answer, 58. I hope you are understanding this. You are kicking and alive. Right, fine. Next question. Right, fine. What is the next question is coming? Very simple question. In a rolling operation using rolls of diameter 500 millimeter, if a 25 mm thick plate cannot be reduced less than 20, there is one plate of 25 mm is given, and in a one stroke it cannot be reduced less than 20 mm, the coefficient of friction between rolls. Sir, it's very simple now. You tell me that there is a one particular roller whose diameter is 500 millimeter. What is that? 500 millimeter is the diameter of roller. That means radius of roller is exactly equal to 250. Wow, kya baat hai? Diameter 500 to radius is exactly equal to 250. Okay, fine. So original thickness of the plate is exactly equal to 25 millimeter, and then in a one stroke, this strip thickness cannot reduce beyond 20 millimeter. So that means in a one stroke, the maximum reduction can be taken place up to 20 millimeter. So how much is maximum reduction here? Delta H max is original thickness minus final thickness after one stage, that is 25 minus 20 is exactly equal to 5 millimeter. So can I say that in a very simple statement, the maximum reduction that can take place will be only 5 millimeter. Do you know the basic fundamental formula for maximum reduction? So we know that, sir, delta H max, kya formula hai? Delta H max is exactly equal to mu square into R. So delta H max you have, a radius you have, you are interested to calculate what? Coefficient of friction. What a big deal. So I'll say 5 is exactly equal to mu square into radius, that is 250, and therefore if you calculate, mu value is coming exactly equal to how much it is coming. Anyone calculated? Yes, you calculate, sir, and mention to me. Okay, right? So I'll say that my answer will be 0.14. 0.14. We can write down 0.14 is my answer. These are all questions asked in what? Previous gate. Very simple question. Ask in a gate examination. Next question. Let's say that sheet metal operation. Iconic question was asked. Very correct, based. 0.14. Very correct. Until and unless you don't jump into the flood, you don't understand how to swim. As simple as that. So jump into the flood, right? With saving your power, energy and the life. Question next. What is that? The force requirement in a blanking operation of a low carbon steel sheet is 5 kilonewton. Right, fine. The thickness of the sheet is T, diameter of the blank part is D. Right. So from the sheet of thickness T, right, we are producing a blank of diameter D. So that for that we required a punch force as a 5 kilonewton. This is what statement. Right, fine. For the same work material, if the diameter of the blank part is increased to 1.5 times d. Now I am increasing the diameter of the blank part to 1.5 times d and the thickness is reduced to 0.4 times d, the new blanking force will be. But the material remains same. If the material remains same, the material properties remain same. That means ultimate shear stress of the body will also remain same. So therefore can I say that, sir, very simple statement. Sir, there is one particular blank of a diameter d. So I'll say that, sir, this is the blank diameter d, sheet thickness t, and there is certain material. So whatever certain material might be, it might be having ultimate shear stress tau u, right? Fine. And for that, the force required to manufacture F max is what? 5 kilonewton, right? Fine. Do you know how to calculate the punch force required in the punching and blanking operation? Sir, it's very simple. Ultimate shear stress multiplied by shear area. It's a blank we are manufacturing. Ultimate shear stress is tau u and the shear area is pi d, circumference multiplied by sheet thickness, that is pi into d into t. And how much it is? 5 kilonewton. So phi is exactly equal to ultimate shear stress into pi into d into t, and this can be considered as my equation number 1. Do you understand that? Yes. I'm doing nothing. Whichever data is given, based on that, I'm just writing down the equation. Nothing else. Nothing else I'm doing here. Is it understood? Yes. Next now. Now what I did, I increased the diameter of the blank to get produced. Now the diameter of the blank is not d, it is 1.5 times d. So it is increased. So whatever the diameter of blank I'm producing, it is a 1.5 times the original diameter. And sheet thickness is reduced to 0.4 times t. It is given 1.5 times d and sheet thickness is 0.4 times t. So can I say that? So here my sheet thickness t1 is a 0.4 times t and the diameter d1 is exactly equal to 1.5 times d. But can I say that material is same? If the material is same, can I say ultimate shear stress will remain what? Same. Material is same, ultimate shear stress is same. Now for this, calculate the force required. So I'll say that force required is maximum force required for first case now is exactly equal to ultimate shear stress tau u into pi d. So what is diameter? New diameter I'll write down like here 1.5 times d, and what is the new sheet thickness? 0.4 times t, and this will be considered as my equation number 2. This will be considered as what? My equation number 2. Let's take a equation number 2 like that. Now I'll say that you take a ratio of equation 1 and 2. Take what? Ratio of equation 1 by 2. Equation 1 by 2 you take it. If I take 1 by 2, can I say that, sir, this tau u, this tau will get cancelled, this pi d t will get cancelled, this pi d and t will get cancelled. So how much it will be? Phi u divided by f max 1 is exactly equal to 1 divided by. Is there anyone who has calculated answer? Tell me that if you calculated answer. If you calculate answer, tell me that. So it will be 1.5 multiplied by 0.4. This is what exactly written here at the denominator. And therefore only one unknown is F max 1. And how much answer is coming? 3 kilonewton. Is it understood? 3 kilonewton. Is it true? Yes. 3 kilonewton. So I'll say that this would be my answer. 3 kilonewton would be my answer. Perfect. Vivek, very correct. Vivek, very correct. So I'll say that, sir, my answer would be this one. I'll get all India rank. How much it is? First. Definitely, if you correctly answered every question, you'll get AR first, or SSC JEE, or engineering services, or any competitive examination you're banking for. Is it true? Yes, we are inching. Next question. Very intelligent question was asked. Right, according to them it was very intelligent, but according to you it's very simple question. Right, shall we go? We are solving numericals one after the other. Fundamentals we are keep on solving. Circular blank of 30 mm diameter are punched from a sheet of 2 mm thickness. If the clearance per side between punch and the die is kept as 40 microns, clearance per side is nothing but radial clearance is given, that is 40 micrometer, right? The size of the punch and the die side should be respectively. Right, tell me now answer. Vivek, you tell me. Beast, you tell me. Jen, you tell me. Right. Then Abhishek, Nancy, then Dilleshwar, anyone who is present there, just try to give me answer. Press the like button. Mark your presence. It's a beautiful concept you are talking about. Right, fine. The days are changing, you have to change. Right, fine. So, sir, I'll tell you that, sir, we are interested to produce a blank of 35 mm diameter. So we know that, sir, blank size is controlled by die size. So if I want to manufacture a blank of a 35 mm diameter, so can I say that die should be manufactured of a diameter 35 millimeter? So straight away I'll say that die size should be exactly equal to 35 millimeter. Are you accepting this? Is it okay? Are you accepting this statement? So I'll say that, sir, straight away, I can say that here, straight away, I can say that here, what I can say that, sir? So die size should be exactly equal to a blank size, that is we are interested to manufacture, it is 35 millimeter. I hope so you are understanding this. Straight away I got answer. And we know that, sir, if I want to calculate now punch size, can I say it is exactly equal to die size minus twice the clearance? And the clearance value is given, that is 40 micrometer. If you convert into millimeter, 40 into 10 to the power of minus 3, that is 0.04 millimeter. Okay, fine. So I'll say that punch size is exactly die size. Die size kitna bhaiya? 35 minus 2 into 0.04. Answer is coming punch size kitna? 34.92 millimeter. 34.92 millimeter. Even in this case also students are making mistake. I don't know what to do a mistake in this. So this will be my answer. Punch size is this much and the die size is this much. But in which sequence? It is asking what is punch size? 35.92. What is die size? 35. So which one is answer? Bombay B is answer. Perfect. Vivek, very correct. Vivek, very correct. Nagaswamy, very correct. 34.94. Kya baat hai? So I'll say that, sir, Bombay B is perfect answer for this. Again, you got all India rank first. We are always getting all India rank first. No issues. Is it true? Yes. Is it true? Yes. Next question. Next question is coming. Oh, we are inching closer to metrology now. We are entering metrology. Science of measurement is very important. Measure the risk. Measure the risk of the life. Measure the capabilities of yourself. Right? Everything. So now we are talking about question next. What is next question? Right, fine. Next question. What is that? Holes of diameter 25 plus 0.02 plus 0.04 mm are assembled by interchangeable assembly with the pins of diameter this much millimeter. The minimum clearance in the assembly will be. So size of diameter, that is hole, is given. The size of the pin, that is shaft, is given, and then they are assembled together, and then it was asked that calculate the minimum clearance. Now this question you have to solve and tell me what is the answer. There is no second thought to it. I think so you should be able to solve this numerical without any doubt. And tell me answer how much it is coming. Minimum clearance. So when the clearance field is generated, so when the diameter of the shaft is less than the diameter of the hole and there is no forces required during the symbol, it is called as what? The clearance field. There is always gap is present between dimension of punch and the die. And if I draw the graphical representation, you will be understand this. This is my punch. This is my shaft, solid shaft. This is hole created, hollow portion. When they are assembled, there will be a clearance or gap is present. Now this will be the maximum material limit. This will be minimum material limit. What is maximum material limit and what is minimum material limit? You don't ask me that silly question now. Maximum material limit is nothing but maximum volume of the material should be present. Maximum material limit. This is what? Minimum material limit. Difference between maximum material limit and minimum material limit is nothing but called as what? Tolerance. Tolerance. It is called as what? A tolerance. It is called as what? Tolerance. And this PDF will be made available in a what? That channel of Telegram. So you just join that Telegram channel and in the evening I'll upload this PDF for your particular pursuit. Is it true? Tolerance. Same thing is applicable over here. Hole is having maximum material limit and the hole is having the minimum material limit. So now minimum clearance, how to calculate? This is the minimum gap is present. So what is this limit? This is lower limit of hole. This is what? Higher limit of shaft. So lower limit of hole minus higher limit of shaft, and this gap is nothing but called as minimum clearance. So if I want to calculate minimum clearance, so we can easily understand here, sir, minimum clearance is exactly equal to lower limit of my hole minus H limit of my shaft. Definitely. What is lower limit of hole here? 40.000 minus higher limit of shaft. How much is the higher limit of shaft? So we can say that, sir, higher limit of shaft is exactly equal to, is it 40? Yes, sir. I think so we are coming. So okay, fine. I have to come here. I should not write down here. This is next question. Okay, sorry. This is not 40. So we have to come back here, right? Fine. So I'll say that, sir, minimum clearance is exactly equal to, so lower limit of hole. What is lower limit of hole? 25.020 minus higher limit of shaft. How much is higher limit of shaft? 25.005. Is it understood? Yes. So what is answer? Very correct. Nagaswamy, absolutely correct. So I'll say that my answer will be coming 0.015 millimeter. This is my minimum clearance. And therefore I'll say that, sir, this will be my answer. Bombay B will be my answer. And can you believe that this question also sometimes come in a GATE examination? So this is my answer. Directly straightforward. 0.015 millimeter. Right? Fine. Next question. Now this is also very interesting question is given, and based on that information only you can be able to solve that. What is it? A hole is specified as 40 and this tolerance is given millimeter. The mating shaft has a clearance feed. So whichever the hole in the shaft they are mating, it definitely has a clearance feed. With the minimum clearance is given 0.01 and the tolerance on the shaft, whichever the shaft is, it has a tolerance of 0.04 millimeter. The maximum clearance in millimeter between the hole and the shaft is. Will you try this question and tell me what is answer? Everybody? Will you try this question and tell me what is the answer? Right? Will you try this and tell me what is the answer in this case? The hole is specified as this, the shaft is specified as this, and then we are interested to calculate what? The clearance, that is maximum clearance. So I'll do one thing that, sir, you tell me that what is the clearance on this particular hole. So 40 is a lower limit, 40.005 or 40.05 is a higher limit. So can I say that tolerance of a hole, can I say that is exactly equal to 0.05 millimeter. Is it true? Yes. The tolerance on the shaft, what is it? Sir, it is given tolerance on the shaft is 0.04 millimeter. Tolerance on the shaft is this much. Right, fine. And the minimum clearance value is given. Minimum clearance, right, fine. So minimum clearance is exactly equal to 0.01 millimeter. Calculate maximum clearance. How to calculate? So I'll give the very simple answer. Very correct, Nagaswamy. C is correct answer. I'll give you very correct answer or statement. You go to this particular formula or the graphical representation. So I'll say that, sir, this is the clearance feed. So this is nothing but my tolerance on the shaft, and the tolerance of the shaft is 0.04 millimeter. Right, fine. This is nothing but tolerance on a hole, and this is nothing but 0.05 millimeter. Now this is nothing but minimum clearance, that is 0.01 millimeter. Right, fine. It was given that this is what exactly minimum clearance, 0.01. This minimum clearance. I am required maximum clearance. What is maximum clearance? Maximum clearance is nothing but when there is assembly taken place of higher limit of hole minus lower limit of shaft. This is the maximum hole diameter, and this is the maximum minimum shaft diameter which can get assembled, and this is the maximum gap can be created. So this is nothing but called as a maximum clearance. So maximum clearance is exactly equal to, can I say it will be summation of this 0.05 from graphical representation plus 0.01 plus 0.04. So it will be exactly equal to 0.05 plus 0.01 plus 0.04, and the answer is coming 0.1 millimeter. Is it coming, everybody? C is answer. Is it true? Yes. So I'll say that, sir, this is my answer is coming. C is exactly my answer is coming. Right? Fine. One more question is waiting for you. Right. A tool with side cutting edge angle, that is 30 degrees. So I'll write down side cutting edge angle diya hai 30 degree. Very interesting question. Right, fine. And end cutting edge angle, CE, end cutting edge angle is given 10 degree. Used to find turn with the feed, and feed value is given 1 mm per revolution. 1 mm per revolution. Feed value is given 1 mm per revolution. Neglecting nose radius of the tool, maximum peak to valley height of the surface roughness produced will be maximum peak to valley height. That is represented by RT. That is represented by RT. Now, if you know and understand fundamentals, you must have went through such kind of surface finish measurement. There is one tool. You can easily understand this is my tool. This is my side cutting edge angle. This is my head cutting edge angle. And this is the profile it will generate. And based on that, there is a maximum peak to valley. This is peak and maximum peak to valley height. It is H. RT can be calculated. And from that derivation, there is one derivation is coming. That derivation you have to understand. And from that it is coming the maximum peak to valley height. Maximum peak to valley height, that is RT, or H is exactly equal to F divided by tan of CS divided by tan of CS plus cot of CE, tan of CS plus cot of CE, right? Fine. And the values are given, therefore I'll say that maximum peak to valid F feed is what? 0.1 mm. Is it correct? Yes, feed is given 0.1 mm per revolution divided by CS. CS is what? 30 degree plus CE, it is nothing but what? In cutting edge angle 10 degree, and then RT value is coming exactly equal to a 0.16 millimeter. And point to be understand that this is metrology problem, but it is being covered in what? It is covered in a metal cutting operation. It is covered in what? A metal cutting operation. Is it true? Yes. So I hope so. You must have understood this particular session. Nagaswamy is very correct. Right, fine. So there is one more session I'll be conducting, that is PYQs for industrial engineering. PYQs for industrial engineering. Industrial, that is IM and OR. IM and OR. This will be conducted at 6 p.m. sharp on a 18th of August. 18th of August. Right, fine. So see you there at this particular sessions, and I'll try to come up with the best possible solutions and the series for you. Is it true? So I hope so you must have enjoyed, and please join the Telegram channel where I'll be putting the PDF of this particular session. PDF of this particular session will be put there, right? So thank you everybody. So take care. Happy learning. Once again, happy Independence Day. Take care of yourself. Keep learning new things. Keep walking in the forward direction. Is it okay everybody? Yes. If you have any doubt, you can write down in the comment section. Sir, allowance can be 0. What is meant by allowance? Allowance is nothing but difference between maximum material limit during the assembly system. Difference between maximum material limit during the assembly system. It is called as allowance. Allowance can be 0. It depends upon which particular, I would say that the fit you are talking about. Right, fine. Whether it is a clearance fit, whether it is a transition fit, or whether it is interference fit. For clearance fit, allowance is positive. For interference fit, allowance is negative. In a transition, sometimes allowance may be 0. Right? Is it coming correct, Nagaswamy? Is it correct? Allowance is nothing but difference between maximum material limit of assembly system. Assembly matlab kya hai? Ek shaft and one hole. And it has 2 dimensions, lower limit and higher limit. Lower limit and higher limit. Allowance can be 0, allowance can be positive, allowance can be negative. Allowance can be anything. And difference between maximum material limit means what? Maximum material limit of hole is lower limit and maximum material limit of shaft is higher limit. So lower limit of hole minus higher limit of shaft. This is called as allowance. And that allowance can be 0 also. Allowance can be 0, allowance can be negative, allowance can be positive. I hope so I'm able to catch your question and able to solve it. Anyone is having any doubt here? Anyone is having any doubt here? If you have a doubt, please tell me that what is the doubt in this case. Anyone is having any doubt here? Okay, fine. Dekho, in which case, let's say that, sir, if I go with the assembly of a standard hole H and the standard shaft H. In a standard hole H and standard shaft H, what will happen? Lower limit of the hole will be what? The basic line. And the higher limit of the hole is basic line. If you go to the standard representation of graphical shaft, this is what exactly a basic line. Okay. This is what exactly I'll tell you here. If I take one particular basic line here, if I come back, and if I take you here, this is what exactly my 0 line or basic size. Then standard hole. Hole can be represented like that. This is exactly my hole is. This is tolerance value of hole. How the shaft can be represented? The shaft can be represented like this. This is exactly equal to my standard shaft H. This is small h. This is H. Right, fine. What is the allowance here? Allowance would be 0. Allowance would be what? 0. When we assemble these two, maximum material limit is nothing but lower limit for hole, higher limit for shaft. This is my hole. this is my hole, and this is nothing but my shaft. If you studied this, and this is basic size, or it is called as zero line. Zero line. Is it true? Yes. So see you in the next session on the 18th evening, 6 o'clock for Industrial Engineering PYQ series. And the PDF of this session will be available on my Telegram channel. Thank you everybody. Take care. Have a happy learning.